Hi, everybody. Last time we talked about the concept of effect size, and now we're going to actually calculate some measure of effect size. Now, if you have not been following these videos in sequence, you may need to catch up a little bit. You may need to go back and see how we calculated the independent sample's t-value before you move into here, although I will give you the numbers that I'm working with. So it's just that if you're confused as to where I got them, it was in a previous video. But let's walk through it anyway. Okay, so one of the most common, probably the most common measure of effect size is something called Cohen's d. Now there are other measures of effect size, and they all have their pros and cons. One thing I really like about Cohen's d is how easy it is to calculate and interpret. Here is the equation. As you can see, it's very simple. Just to walk you through it in words, this is the mean from group 1 minus the mean from group 2, which we already had to do anyway to calculate our independent sample's t-value. Then we divide that difference by the pooled standard deviation. Okay, and I showed you how to calculate the pooled standard deviation in a previous video when we calculated the t-value. However, I'll also demonstrate to you how to get that just one more time in case that there was any kind of confusion. Let's take a look at that right now, in fact. So here, of course, is the independent samples t equation, and you'll recall perhaps that this red portion is the pooled standard deviation portion of the equation. Now, the confusing thing here is it's not just the denominator of the equation, because as you can see here, to get the denominator, we multiply the pooled standard deviation by this, but before taking the square root, then we take the square root of this product here. And that's not actually what the pooled standard deviation is. The pooled standard deviation is the square root of this portion before it's multiplied by that. Okay, so just make sure to go back to this portion. Now I'll show you with our data, the values from our data set here. So again, going back to the previous example we've been working with, this is the mean of group 1, the red pamphlet's mean score on the fire safety knowledge quiz, and this is the mean score from the green pamphlet group, 6.83. And so of course if you go through all of our math and you can go backwards to see how we got this, this is where we ended up just before multiplying those together and then taking the square root to find that denominator. So what we're doing here is just taking the 2.41 and taking the square root of that, which gives us the pooled standard deviation. So you can ignore this section, this portion here, to get the pooled standard deviation. Now, of course, once you do the math, the square root of 2.41 is, of course, 1.55, and then it goes on for a while, but I'm rounding to the two decimal places, which is perfectly fine. Okay, so that's how we obtained our pooled standard deviation. Now we need to plug it into the equation and we'll work out the math. However, if it bothers you that we have to go back and find our pooled standard deviation in our previous math, you could use this equation instead to calculate D if you still have your raw data, for example, and you've already got those calculations. So I like to do it in a table as I've demonstrated before. You could do the same thing, just go back and find all those values and plug them into this equation to find the value of Cohen's D. Of course, we've already done all of that. We already plugged in all of the information, and so we don't need to do it again in this video. Okay, so in any case, what we end up with then is a value for Cohen's d of in the numerator was negative 2.26. In other words, the difference between our two means was negative 2.26. And then, of course, as I just demonstrated on the previous slide, our pooled standard deviation for these data is 1.55. This divided by that, of course, equals negative 1.46. Okay, now we need to get to an interpretation of what that means. Okay, before we move on, I forgot to mention that Cohen's d actually is named after a person. Cohen is the last name of a very famous statistician, Jacob Cohen. Anyway, that doesn't really matter exactly, but I wanted to pay homage there just a little bit. So the interpretation of Cohen's d is actually fairly straightforward. In fact, it's very analogous to a z-score. You'll recall in a z-score, we took the difference between a single score and that score's distribution's mean, divided that by the standard deviation of that distribution. Very similar here, except we're taking the difference between two means and then dividing that by their shared or pooled standard deviations instead of just one sample. And so essentially what we're doing is interpreting a Cohen's d as the distance in standard deviation units between two means. In other words, because we obtained a Cohen's d value of negative 1.46, what we're saying is the mean of group 1 on the fire safety quiz score is 1.46 pooled standard deviations away from the mean of group 2, or the green pamphlet group's fire safety score, fire safety knowledge score. So in other words, the means of those two groups are 1.46 standard deviations apart, specifically pooled standard deviations. Now, a little note here that I think is important is it's a negative 1.46, and I didn't say that they're a negative 1.46 standard deviations apart. In fact, that's pretty interesting because it doesn't matter actually what the sign is of D. It doesn't really change your interpretation because you can't have a negative distance apart exactly. At least that makes my brain explode a little bit. They're just 1.46 standard deviations apart, regardless of which mean was actually bigger than the other. So in interpreting Cohen's D, you can essentially just ignore the sign. It doesn't really change anything. Okay, anyway, let's take a look at this graphically and you can see more what this means. Okay, so if we were to graph this, we might get something like this. So we would see the red group, the group that received the red pamphlet, I should say, over here, and then the group that received the green pamphlet over here, okay? And roughly distributed in this way, although really it was too small of a sample to graph it perfectly, but imagine that this basically represents what we're doing. I'm being a little generous here. So the mean of the red pamphlet group, the mean quiz score on the fire safety test was 4.57, and the mean score on that same test for the green pamphlet group, the people who received the green pamphlet, was 6.83. And so essentially what I'm stating here is that with a Cohen's D of 1.46, in this case negative 1.46, which as I said doesn't matter, that means these two means were this many pooled standard deviations apart. And so if these little tick marks represent the pooled standard deviations, and I kind of visually estimated it there, that's essentially what that means, is that they're that far apart. Now, what is interesting here is just how distinct these peaks are from each other, and especially given the standard deviations of both of these units themselves, both of these groups themselves. So this is a really nice interpretation. Now let me give it a little bit more, however, in terms of verbiage. So in words, if we think about the size of a standard deviation, 1.46 standard deviations is relatively large. If you recall, 68 point, well, a little bit more than 68%, I'll say, of data fall within one standard deviation of a distribution's mean. You remember that from our z-score section. And so as we approach 2, that's 95% of all data points fall within 2 standard deviations of the mean. So for 2 means to be approximately 1.46 standard deviations apart, that's pretty big. That's kind of a big difference between those 2 means. So that's maybe not all that helpful. If you're in doubt, not sure how to interpret the size, just use these guidelines. Again, these are somewhat arbitrary, of course, but you can go ahead and use them, and that's fine. So in other words, if you have a Cohen's D value that is about 0.2, positive or negative, that's called a small effect size. If it's any smaller than that, I would probably say it's very small. In fact, it's almost negligible, depending on whether there is statistical significance or not. That might help you interpret that. And then anything about a 0.50 and approaching a 0.80, positive or negative, I would say is a medium effect size. Then a large effect size starts at 0.8, again, plus or minus. So of course ours is 1.46, which is almost double the large effect size. So that's a very big effect size. Okay. Now, of course, I made up these data, right? This wasn't a real kind of experiment. I just said, hey, let's imagine we did this thing and we actually didn't do it. We also had small sample sizes, and so that would make me be a little cautious about any kind of interpretation. But if I were to obtain this kind of effect size in real life, I'd be very surprised. I would say that's a very large effect size. You don't usually see something like that. So if you recall, we had an in-word interpretation of our t-test. This is in the calculating t, the t value. So we'll just revisit this really quickly. Everything we found so far using this example of the red pamphlet, green pamphlet group suggests that we can go ahead and reject our null hypothesis that said that there was no effect of the pamphlet on the quiz scores. We can now say it really looks like there is, right? We already knew that with our statistical significance. So we can go ahead and reject that null hypothesis with a very low probability of committing a type 1 error. In other words, being wrong about rejecting our null hypothesis. We can get more specific and say it looks like those who received the green pamphlet actually did quite a bit better than those who received the red pamphlet in their test of fire safety knowledge. And I could say it just wasn't probably, it seemed to be big enough that we could measure it with some reliability. We'd probably see it again, for example. But also now I can have this additional information, the D value there, the Cohen's D value that says it was a big effect. Okay, that's essentially what's interesting here about the effect size. So people who got the green pamphlet version did on average much better than those who got the red pamphlet version. And as long as I did my other research methods carefully, I can essentially attribute that difference to which pamphlet they got, especially if I randomly selected and randomly assigned the people. Okay, so now at this point, not only can I say that there was a difference, that was statistical significance, but now I can also say it was a large difference. Which pamphlet they received made a big impact on their knowledge score of fire safety. So now I can say I really strongly recommend that you start giving the green pamphlet version to everybody if you want to improve their fire safety. Okay, that is it for Cohen's D. The next thing we're going to do is something called confidence intervals. It's a new kind of idea and also considered one of these new statistics, but it's fun and interesting, so I'll see you then.